I'll stand here. So that we're
Yes.
the cameras. All right. Well, thanks everyone for being here. My name is Bonnie Keeler. I'm a faculty member here at the Humphrey School of Public Affairs in the Center for Science, Technology, and Environmental Policy. And I am here on behalf of Terin's committee. So Janet Johnson, Gabe Chan, Steve Pulaski, Forrest Fleischman, who is joining us via Zoom. And it's our pleasure to introduce Terin Mayer for his dissertation defense talk. So I wanted to say a couple words about Terin before he gets started. And the first is to say that this is not only a significant milestone for Terin as he completes his PhD studies, but it's also sort of a personal milestone for me, and that Terin is my very first PhD student. And so it's a really big deal. And I actually remember talking to you on the phone before I started this job. I had accepted this position, but I hadn't actually started at the Humphrey School. And we were having this conversation about Terin's interests and what he wanted to do. And I remember thinking, if this is the caliber of students that I'm going to get to work with here, then this is going to be such a great job. And so we talked a lot about your research interests and your career goals at that time. And that was the first time I really heard Terin articulate his interest in water governance and thinking about freshwater institutions and managing common pool resources. And so not all students come in with a clear idea of what they want to study and then end up actually doing their dissertation on that topic, but that's actually what was true for Terin. So he came in with a really well articulated set of research goals and ideas. And as you'll hear today, he really executed that and has distinguished himself as an expert in institutional and governance dynamics of water quality and water quantity issues. And a couple things that I think have been particularly impressive about his PhD journey. So he took a lot of initiative as a student to really broaden his methodological toolkit. He took advanced coursework in economics. He's got 2 economists sitting on his committee here. He's become an expert in some very sophisticated analytical techniques that are very far beyond the expertise of any of his committee members. And you'll hear about some of that today, like his work in social network analysis. He's also pursued partnerships outside of the university. So he worked as a project manager for the Climate Impact Lab, and then formed a really productive collaboration with the Freshwater Society on groundwater governance that was multi-sector, multidisciplinary, lasted several years, and has ended up being part of one of the dissertation chapters that we'll present today. And of course, there's been a lot of life that's happened along the way. At least one move that I know about, at least one baby that I know about. Pandemic, teaching responsibilities, a lot of career choices, even a late breaking ER visit from his toddler. So anyway, just completing a dissertation and for anyone takes a ton of grit and perseverance. And I think Terin in particular has demonstrated just a lot of tenacity and independence in the face of all kinds of challenges, and just a really remarkable journey that's been fun to watch him on, and I think will serve him well in his future position. So he's starting a role as a deputy research director of the Blue-Green Alliance. So super exciting things ahead. Really grateful for all of you being here to show support for Terin as he presents his dissertation. And I just ask that you reserve questions for the end. We'll have time for Q&A from the audience, both of you in person and online, before we dismiss you for his committee. So thanks, Terin.
Thanks so much. That's a very kind introduction, and the tearing is entirely due to that and not due to the fact that my toddler jabbed her thumb in my eye on Sunday night and scratched my cornea. Then, so that's if you see me put in some eye drops, that might be the reason. But thanks all for being here. So to start, I'd like to tell a story, and once I get my slides going here. So this story starts in 1878 when the explorer John Wesley Powell, who was charting much of the arid western United States, and then the director of the U.S. Geological Survey wrote a report back to Congress saying, hey, I think we should reorganize the states to match watershed boundaries. He foresaw that water was such an underpinning necessary resource that for an agricultural society to flourish and to avoid all kinds of conflicts, it would be better to match the actual spatial scope of watersheds. Obviously, that did not happen. In fact, the railroad interests that had huge land holdings in the American West lobbied very hard against that conservation-minded proposal. But for anybody like me, however many decades later, who looks at the maps of the states and counties against the backdrop of the watersheds of North America, or even the principal aquifers, it has a kind of intuitive appeal. How is it that we're able to live our life with such dependence on water, and the administrative structures in which we sort of manage our interactions with that crucial part of underpinning of society are so different? And so that's, fundamentally, because water transmits our interactions with each other across boundaries, and there are these external influences that are sort of outside of what we typically think about when we're interacting with each other in society, it gives rise to collective action problems that have become what I think of as a kind of an underpinning for much of public affairs scholarship. And that's what my dissertation is about. So I'll tell you a little bit about sort of the general conceptual framework in which these three essays rest, and then I'll tell you a little bit about each of my projects and their findings. I'm joining a very massive arena of scholarship that looks at the intersection between nature and society. A scholar that I really like, Clark and Harley, that Gabe turned me on to, have sort of done a big review of what's called sustainability science, where they've identified over a dozen different sort of research paradigms that fall within this intersection. And so I've done work to try and narrow in my focus, in part by sort of following my curiosity about public sector actors. And in particular, I'm really curious about public sector actors that tend to be sort of overlooked within the political science discipline. So states and their agencies, that's present in the literature, but tribal governments and local governments especially have tended to be not as much of a focus in the political science literature compared to, say, Congress or the presidency. I'm also really curious about policy institutions. And now institutions, it's important to think of like the way that I'm using the word institution is like when you hear people say marriage is an institution. It's a set of rule-bound collective decision-making processes. It's not one specific organization. It's more of a sort of set of norms or a broader set of policy processes. And the three that I've specifically zoomed in on are cost-benefit analysis, which is a big part of environmental policymaking, international collaboration, and institutional collective action. Those are sort of three sub-themes that you'll see later on in the presentation. And then in particular, I'm really curious about freshwater resources. So these are, the surface waters, the lakes, rivers, wetlands here in the upper Midwest that have been sort of captivating my imagination, but then also groundwater of various depths and qualities. Any water that's in sort of the underlying geology is held there and supplies a lot of the economic and ecological life in our area, and then also their interconnections with each other and the water cycle. So that's kind of what I mean by freshwater resources. So when you sort of draw this kind of Venn diagram, that gets you to where I've focused my my dissertation studies, which is in what I call freshwater governance, or the variety of interdependent policy institutions used by a diverse set of actors to manage inland lakes, streams, wetlands, and aquifers. So within this sort of study of freshwater governance, in which there are plenty of other researchers. I have focused in on what I think of as three sort of open questions for my three essays. First is, what might current policy institutions be missing in accounting for the benefits of pollution mitigation, water pollution mitigation specifically? Second, what institutions impact aquifers in a region, our region, where most of the focus has been on rivers and lakes? And thirdly, what happens when a state mandates that cities collaborate at the watershed scale to manage stormwater? So these three questions we'll touch back on with the three essays that I present in a second, but here's sort of my case to you as to the contribution that I'm making to the study of freshwater governance is that I'm tackling these three sort of open questions. So let's start with this first one. What might current policy institutions be missing when they account for the benefits of pollution mitigation? And that gets us to this first chapter. The health damages attributable to drinking water nitrate contamination, magnitudes, distributions, and uncertainties. And this is joint work that I've done with Bonnie and had a great opportunity to do work with Ryan and other folks in Bonnie's lab over the years that have built up this study. These are all of the are a selection of the water towers in Minnesota's municipalities, which makes up this sort of underlying study here. And you can see the water of a municipality is both very significant, very prominent in the community, and kind of like part of the iconography that municipalities identify with. This paper looks at a paradox in the value of water. So on the one hand, water pollution has been a top concern for US public for over 2 decades. So if you ask, and as Gallup does, what are your top environmental concerns? Water is frequently top of that list, and clean drinking water in particular. But analyses of pollution mitigation efforts in this arena have struggled to find that benefits exceed their costs. So it kind of leads to this paradox of like, if it's that valuable, why is it that the benefits don't exceed the cost when we do these economic analyses? So our paper looks at a leading explanation, sort of bolsters that leading explanation by sort of arguing that there are uncounted benefits, especially in the realm of health costs. So let me tell you a little bit about what we did. The sort of intellectual effort, the analytical effort undergoes to link drinking water nitrate. So nitrate is a common fertilizer applied to agricultural fields around the country, and it's also a criteria contaminant that is whose concentration is monitored by municipalities and by the EPA and the State Department of Health. So we link nitrate to the risk of adverse health conditions. And then from counting up those cases, we attribute cost figures to those health damages. So specifically, we're going to look at each public water supply in the state of Minnesota. That's 675 of them. And we're going to count up disease incidences for 15 different adverse health conditions, the broadest set that's been captured in this literature so far. And a whole bunch of other sort of like demographic information at the public water supply level. And then we're going to use what's called the attributable fraction of disease model that basically tries to ask the question, of the expected number of cases, so the number of cases of a disease that we find associated with this public water supply, how many were associated with excess nitrate exposure, given the contamination levels, exposed population, and anticipated risk. That allows us to attribute a fraction of the realized disease that we think is associated with the elevated risk based on epidemiological studies that we've worked with. And then from there, once you have a count of cases, you can actually do some accounting to say what are the likely direct costs of treatment and hospitalization, and then what are the likely indirect costs in terms of avoidable fatality and quality of life impacts. So that's sort of the analytic arc. We do that, and the result that I want to show you. So in addition to sort of calculating what what we expect the damages to be in Minnesota presently, which is 5.5 billion annually. To put that in context, the most recent biennial budget that was passed was like 55 billion. So it's like a tenth of a yearly state budget. But what I want to show you is a result that we looked at to try and answer the question: how big could this potential damage be, given the fact that the contamination levels are below the federal maximum contaminant level? So the federal government says 10 milligrams per liter is where regulations will kick in. You're not allowed to go above that. And most of the state of Minnesota is frequently below that. So we asked the question, all right, if you added just an incremental little bit of nitrate contamination to all of the cities across the state, and then calculated the damages based on that, what would that look like? And that creates what's called the damage function, which basically sort of associates this marginal increase in contamination with an expected annual average avoidable health damage. And so that's what I'm going to show now. And just for point of reference, so each little bit in either of these directions is you're adding a little bit to the average nitrate, to the average water supply, public water supply in the state of Minnesota. We took a prior estimate of the social cost of nitrate, which is sort of or nitrogen, which is sort of a baseline, sort of trying to capture the social cost of water pollution. And it's really small. It's about, that's like close to $30,000 in these terms. But you'll see this actually axis is in the millions. So what we find is that the plausible damages underneath the maximum contaminant level are potentially quite large. So this number, for point of reference, is an estimate of the costs associated with pedestrian crashes in the state of Minnesota, 68 million, and an estimate of the avoided health damages from the Clean Air Act is 143 million. So you can see the potential avoided damages from nitrate contribution is potentially quite large. I want to be clear that the band here that I'm showing you, in typical graphs like these that you'd see in a scientific journal, that's typically representing the 5 to 95% confidence level. This is the interquartile range, so 25% to 75%. So if we did the typical thing, it could be indiscernible from zero. So there's a lot of uncertainty in these estimates. But we present it this way because we think some municipalities might actually want to be taking preventative action, even just looking at the more probable than not kind of view of this. One interesting finding here is that in prior studies have looked at these health outcomes and focused on panel C, which is cancers. But as you can see in panel B, which breaks down this damage function by category, cancers are actually, in our estimates, a relatively small part of the damage. Instead, it's birth anomalies and hypothyroidism and vision anomalies that make up a larger part of the damages. And these are longer lived, but typically non-fatal health conditions. So that's a significant story. I'll also mention that these damages are quite unequal. So part of it is drawn from the inequality of nitrate contamination to begin with. So this is a sort of a histogram type figure of the exposed population by nitrate concentration. So you see most of the state of Minnesota gets basically no nitrate exposure at all. But then you have a very small portion of the population that is exposed to these higher nitrate contaminations. Another way of looking at this is here in panel B, what we do is we take every city and we order them, we line them up from poorest to richest along the x-axis. And then we count up the amount of nitrate exposure that they've received cumulatively. So what this is showing you is that once you get to 10% of the population of the state's wealth, that those cities that account for 10% of the state's wealth account for close to 90% of the nitrate contamination burden in the state. And I've marked along the x-axis, the USDA provides a simple categorization of communities into rural versus urban. And those markings indicate the rural communities. So basically the current nitrate contamination burden is being held primarily by rural communities that have the least wealth or community resources to deal with the health damages. For sake of time, I'll skip these next slides, but you can then look at how the damages of the different health conditions are either more or less egalitarian in their distribution. So I'll mention, I think that this work has implications for determining the nitrate maximum contamination level. And I'll focus on just a few things. One, it seems like there's mounting evidence that avoidable health costs materialize at nitrate contamination levels well below the 10 milligram per liter. This research is just joining a broader set of epidemiological studies that have been making this link. The other significant point is that valuation methods that incorporate only avoided fatalities, which is actually the requirement in cost-benefit analysis under the EPA, may miss substantial benefits of avoiding non-fatal but long-lived health outcomes. So the way that we're calculating the potential health benefits might be missing significant avoided quality of life impacts. And then I think that the choice of evidentiary threshold, this is one thing that I've been thinking about when wrestling with the inequality question, is that you have to choose what evidence is good enough to change the maximum contaminant level. But in doing that, if you say that the current amount of evidence is not good enough, it might actually mean that that the distribution of damages on those that are least able to deal with them is going unchecked or is okay, right? So there's this question of what the right evidentiary threshold is can't, in my mind, be disentangled from some equity implications that are important for us to be considering. All right, so that's so much for question one. Question two, what institutions impact aquifers in a region where most of the focus is on rivers and lakes? So we're going to take a shift here in our focus and look at the entire Great Lakes region. And this paper I call not an absence, but a profusion, groundwater governance and institutional complexity in the Great Lakes region. This is a very descriptive study. Our contribution is not as much about testing hypotheses as it is adding to actually a very minimal body of evidence that looks at groundwater and groundwater governance as connected to a social ecological system. So my argument here is that the Great Lakes case adds unique value to the limited set of groundwater governance studies. And I'm going to show you a map of the region that I think helps make that case in a second. Most studies of groundwater governance are in arid regions. That makes sense, right? I mean, that's where most of the, you'd focus on areas where the largest endowment of water for use is in the ground, and people are going to be paying attention to that. By contrast, there's few places in the world that you could imagine having more water than here. this case also provides a sort of a distinct combination of factors that haven't been looked at in case studies in groundwater governance. It's cross-jurisdiction, it's multi-scale, and there's strong tribal government presence. So I'll show you this map that looks a little bit overwhelming, but I'll walk you through it. So for one, these sort of star or circle cross symbols are the approximate location of the tribal governments in the region. So a very strong presence, and tribal governments have sort of legal standing to manage the water and the landscape in their territories, not only in their own reservation lands, but also in ceded territories that they've maintained some rights to across the region. I've also, to sort of signal some of the underlying groundwater use pressures, I've taken the census tracts and colored them gray if they're metropolitan, colored them green if they have a majority of their landscape under cultivation. And then when they intersect, you get that dark green color. So you can sort of see these areas where both domestic sort of human urban pressures might be drawing on water supply, while at the same time, a lot of agricultural lands might be drawing on water supply. And then this blue boundary is the boundary of the Great Lakes Basin. So the Great Lakes surface water watershed is also incorporated into the Great Lakes Compact and Water Resources Agreement, where all of these states, plus the two ones that aren't pictured on the east, plus the Canadian provinces, have basically agreed to prohibit diversions outside of the Great Lakes Basin. So keep the water in the basin, in the bathtub, so to speak. But what I find really interesting about that is that if you actually look at the aquifers that intersect the basin, many aquifers cross that surface water boundary. Now, the Great Lakes Compact is prescient in not drawing a distinction between surface and groundwater. They say this covers groundwater as well, but in practical terms, the boundary that agreement is sort of based on is very surface water focused. So this is sort of part of the landscape that I think is interesting, and this is not a major finding of this talk, but each of these aquifers, in principle, you could imagine having some co-management institutions built up around, and we don't really find those. And the forum of the Great Lakes Compact, you'd imagine would want to pay especially close attention to aquifers, but it doesn't. So there's a forum without aquifers and aquifers without forums, and that's sort of in keeping with what you'd expect in a water-rich place. But that's not the only thing that we found. So if you were to look only at the water use policy institutions in the Great Lakes Basin, what you'd find is that each state has its own sort of reporting and registration requirements to manage and to at least know who's withdrawing groundwater and for what. And that gives us this view that have some time series and basically some distributions of the major categories. But we thought that probably wasn't going to be enough because it's not sufficient to just sort of open the statute book and do control find like every time that it says groundwater to actually capture the institutions that are impacting groundwater. So we went about building a relational database of 251 actors and 280 policy institutions, and then over 1,000 unique relationships between those actors and institutions to try and capture the sort of institutional context in which groundwater governance was developing. And so what you can find is, so this is how we did it. A bunch of stakeholders interviewed, a bunch of legal review. This work was with a large team with Freshwater Society, as Bonnie mentioned, and we did curation and analysis of a bunch of data sets, and then a systematic literature review of 45 policy and science reports. And so I'm going to just present you a contrast between Illinois and Michigan, but these visualizations that I'll show you, we've done for all the states. So in addition to the groundwater withdrawals, what we looked at was, all right, how are they participating in a whole set of different policy institutions? And who else is participating in those policy institutions? And how does that differ from the withdrawals that we find? And let me sort of share with you a couple of key observations here. First, just to help with reading this, the size of the actor node here is proportional to the count of that type of organization in the state. So you can see sort of the different sizes in the different states. The weight of the link is proportional to that actor type participating in that policy institution. And then the size of the institution node here is proportional to the number of incoming ties. So I want to make a few observations here. One is, this maybe goes without saying, but withdrawal institutions are embedded in institutions set up by other laws, right? So these, the groundwater withdrawal institutions might be the narrow focus that you take on groundwater, but the National Pollution Discharge Emission System and the underground injection control and the Safe Drinking Water Act policy institutions, these are set up by the Clean Water Act and the Safe Drinking Water Act by a bunch of other federal laws, which are regulating the same industries and set up sort of a policy status quo. Even though they're not directly related to groundwater, they are part of the groundwater governance system, I would argue. Two, the size of the groundwater user groups obviously differ by state, which is likely manifest to different, which likely manifests in different policy dynamics and political dynamics across the states. So here, for example, you can see the distribution of water providers is different. It favors private utilities in Illinois versus public sector government suppliers in Michigan. And part of what this also shows is a concentration of benefits. So consider that a smaller number of industrial firms, for example, make up a larger proportion of the registered withdrawals. So, and the concentration of benefits is, scholars believe, is a key part of sort of predicting the type of politics that is likely to manifest in that kind of issue. The other thing that you might see is, so the federal government, this node and that node, they're the same. They're just repeated in the pattern in the two panels. So if you were to look at all of these actually in just one sort of connected web, what you'd see is that there's a relatively small number of relationships that cross states. So there's a lot going on within the states, but a few fairly important links across states. And then the one other sort of subtle but important thing is in Michigan, you'll see the tribe node connects with the other state institution nodes, whereas here in Illinois, the tribe node only connects to the other institution node. And that's because there are no tribal governments in Illinois. So in Michigan, the tribes are connected both to sort of regional institutions, and they're making their presence felt and having a sort of stakeholder interaction in the state-based institutions, but otherwise in other states, they're having to sort of interact sort of indirectly. And that's, and then the other thing that you'll start to see is these kind of like triangle or clustering patterns, basically sort of where are the links more rich. This is not a great way to analyze that. And so I'm going to pivot to a different sort of method that I've used to analyze it. What's frequently done in a network analysis is, what I presented to you is that there are nodes that are of two types, actors and institutions. And that's what's called a bipartite network. But that's harder to analyze than a unipartite network, which is made up of just one type. And it turns out that you're actually able pretty simply to collapse the bipartite information into a unipartite graph. And the way that you do that is, So say you have this scenario where an actor participates in policy institution X and Y. You convert that basically into policy institutions X and Y sharing a participant. So instead of it being a separate node with two ties, X and Y are policy institutions that are connected by sharing participants. And you can do the same thing in the reverse, where two actors encounter each other in a common policy institution. So just doing that allows us to look at some interesting patterns. So here's all the different types of policy institutions that we captured. And these are policy institutions that are connected by state agencies. And what you'll see is that there's a degree of specialization basically going on. That the state agencies have specific lanes of policy making that they're focused on, and that they connect across different types of policy domains. But then there's whole areas where policy institutions are not actually connected by state agencies. And the contrast that I want to show you is with the policy institutions that are connected by tribes. So what we find is that that tribal governments have to connect across a whole host more policy institutions that might conceivably be affecting groundwater than do the state agencies. And so looking at that, like the argument that I think that this suggests is that tribal governments are actually poised to provide some fairly important leadership as we work to try and integrate the various diverse policy institutions that are impacting groundwater, but not especially intentionally. So if you were to try and figure out how you get all of these diverse policy institutions that have been built up over the years, trying to solve problems that are not directly related to groundwater and actually make them harmonize into something greater than the sum of their parts, the tribes are in a really good position to be able to tell you what's working across purposes or how to unify multiple different policy processes under the same sort of plan. Now, it's a little bit difficult to tell just from this view. They're also really small. So the tribal governments are small organizations. They may not have had to differentiate themselves into different subunits in the way that states have. So it's a little bit too soon to tell that that's inherent to tribal government. But that said, in our interviews, it definitely came out that tribal governments are trying to manage water resources and natural resources in a more holistic way. So it's a little bit TBD there. The last point on this paper that I'd like to make is a cautionary note. So if this talks about the potential leadership that tribal governments can deliver, there's some warning signs that it's possible that the same sort of history of marginalization that tribal governments and indigenous people have experienced in this area is just reproducing itself. And to show this, I want to talk a little bit about sort of triangle patterns. So in the public, in the sort of network science and public administration literature that looks at networks, triangles are the most basic forms of clustering that have been identified. And that's actually true across all network studies. But think of it like a friend of a friend, right? Like you could imagine if I know somebody and I know somebody else, and then they know each other, that sort of friendship formation is especially stable, for example. So theorists of public affairs have sort of translated that idea into this context to say triangles are especially helpful for trust building. You have redundancy. They're the kinds of situations that would allow for mutual accountability and mutual monitoring, and that redundancy can conceivably help to build trust in complex policy processes. So looking at triangles then, what I look at here is the network of actors participating in policy processes that are focused on groundwater quantity. So that's a subset of the entire data set. But if you just take sort of three different actors, they form triangles at about 85% of the time. But if one of those actors is a tribal actor, that triangle relationship appears only 13% of the time. So it's much less probable. Similarly, if you were to look at the network of institutions connected directly or through non-tribal public sector actors, what you'd find is sort of a similar pattern. Here, if you've got, well, actually, so I'm going to show you, this statistic is actually about triangle closure. So this asks, it's similar in spirit, but it asks if Z and X are connected and Z and Y are connected, what is the probability that X and Y are connected? So out of all two paths, how many of them close into a triangle? So here, if the arrangement is without tribes, you get close to 80%. But if it's with tribes, it drops to 51%. So triangle closure happens less when you're specifically looking at the policy institutions that have tribes participating in them. So these feel like potentially warning signs that the degree that maybe tribes are in a good position to lead, but they might also be being cut out of some of the policy processes, maybe intentionally, maybe not, right? So writ large, because of the huge diversity of policy processes that we studied, the sort of takeaway that I think about is that this the groundwater governance in our region is risking kludgeocracy. Does anybody know what a kludge is? Have people heard this term? No. This is a kludge. So the idea is it's a short-term solution, potentially effective, but in the long term, clumsy. And I'm borrowing this term from a political scientist, Stephen Tellis, who says, when you add up enough kludges, you get a very complicated program that has no clear organizing principle, is exceedingly difficult to understand, and is subject to crashes. So I think that is the sort of warning sign. When you look at a natural resource that hasn't been the focus of intensive policy and institutional development, it's not that you find an absence of policy institutions, you find a profusion of them, and but they're not particularly organized around a distinct goal. And I think that means that you might risk a kludgeocracy developing instead. All right, so the third paper here is more like gym class than pump priming, the effects of a mandate to collaborate on polycentric urban surface water management. What's that about? The overall question is, can you mandate intergovernmental collaboration, right? Lots of studies have found that collaborating across governmental bodies and across boundaries is a good idea, right? It tends to make sense that if you have natural resources that cut across political boundaries, it makes sense that collaborating across them would render benefits. So much so that you might wonder, well, can we just make people do it? And that's sort of the question that I try to answer with this. There's a rich body of research on what's called polycentricity, which is kind of, if you break down the word, it kind of is what it sounds like. There's multiple centers of power. And collaborative water governance has been a part of the study of polycentricity for a long time, for sensible reasons. But little is known actually about the effects of a mandate to collaborate. And there's also a dearth of studies of polycentric networks over time. So my contribution here with this paper is a longitudinal study of Minnesota's 1982 Metropolitan Area Surface Water Management Act. Act in 1982 responded to a bunch of studies that were being produced in the metro area saying surface water management is a mess here. It's costing lots of money because we're not coordinated. There's even one little passage in a Metropolitan Council testimony that I saw that said the town of Eder was wiped out. So dire consequences. So the Management Act said, all right, municipalities in the metro area, you have to organize yourselves under watershed management organizations. And it mandated that happen. So what I did is I gathered a bunch of evidence through archival investigation and longitudinal network modeling. So part of this was what's known as process tracing, which is kind of like investigative journalism in a sense. I looked for all of the documentary evidence that you would expect would be in archives for this kind of thing. If the mandate functioned, you should see a bunch of local governments producing plans and reports. And indeed, these archives at the Minnesota Historical Society, put together by the Board of Water and Soil Resources, provide that sort of archival evidence, which I collected. And then I also used a process called temporal exponential random graph modeling, which basically through all that archival evidence, I was able to identify the history of how these collaborative networks change over time. With that longitudinal data, you can use this modeling approach that tries to disentangle the different small scale processes that result in the network that you see. And that's what I did to try and answer some questions, which I'll talk about in a second. So here's some of the evidence. From 1970 to 2011, what you see is watershed management organization activity that sort of fits what you'd expect if a mandate worked. So you see a bunch of watershed management organizations get formed in the years after the law passes. Then they are involved in some shared budgeting activity, and then that develops into approved plans. But you'll notice that the intensity, the color, as represented by the color scale, goes down, right? So a lot more of them create these watershed management organizations than successfully get to an approved plan. And fewer. Some of them sort of jointly budget, but not all of them get all the way there. I also looked at public financial data collected by the Census of Governments to try and figure out if this was actually going to work, and if a lot of money was on the line, as the archival evidence showed, there should be some signal of it in the public financial records. And this is the clearest signal that I found is actually in the total municipal capital outlays. So think about water resource management in an urban context. It's a lot about the built environment. It's about the way that these cities were messing up is that they would build their stormwater systems right to the edge of their city, and then a bunch of water would just dump into the neighboring city and not get managed particularly well. So the clearest place where you could see a signal would presumably be in the capital spending. This is like hard evidence to parse in some ways. I've organized all of these cities by the year that they adopted a watershed management organization. So there's two major cohorts in 1984 and 1985. And then as a point of comparison, I look at all of the cities across the state that have never adopted watershed management organization. So if anything, it seems like there's a relative pause in capital spending in these years, shortly before and shortly after the act passes. But it's not super obvious that that has to do just with the act, right? It could be any number of other things. In particular, if you spend a bunch on capital investments in early years, naturally, you're not going to have much need to spend on capital investments later on. This is also just total capital spending, not water specific capital spending. So if Edina decided to build a park center there, that's in there too. So I would argue that there's not as much evidence in the actual financial impacts as you'd expect. My last sort of analysis in this paper has to do with the sort of network dynamics. So here, each black dot is a city, a county, or some other form of local government, a township. And the open dots are the watershed management organizations. So you see there's this sort of complex network pattern that's emerging around this time when the act forms. That you see a lot of these watershed management organizations get formed. And then there's sort of decay, like death and decay and reorganization that happens. I've presented this in kind of a petri dish form, but obviously this is a spatial problem too. So there, you're not seeing these local governments bounce around the metro. In the modeling that I do, I account for that by constraining the types of partnerships that are possible by the geography. And when I look at this, I'll just see if I can get it to play again. When I look at this, I have sort of developed two sort of overall hypotheses about what could be going on here. One is that the mandate could function like the priming of a pump. So part of what you see is there's this clustering sort of around the existing watershed management organizations. To me, that seemed like maybe that's consistent to the benefits of collaboration and positive network externalities providing their own momentum. So, a city joins a watershed management organization, they say, hey, this is actually working for us. Then other cities in the local neighborhood join that watershed management organization. And you'd see this sort of accumulation going on. The other possibility is what I've thought of as the mandate as a gym teacher. It's like it forces the resolution of coordination problems. It says you're all going to play together, but the resulting exchanges are shaped by the local government power dynamics, right? Like the gym teacher can't make everybody play, can't make everybody play nice, and can't really decide what rules are favored because those rules might be favored just based on the local government power dynamics. So I won't go into the ergom details, the modeling details in the public presentation, though I'm happy to talk about that with the committee. But on the whole, I find that the burden of evidence, so the pump priming, just to go over this again, the local governments would start collaborating, see benefits, and are more willing to jump on board. In the gym class, the local governments would approach collective action with caution. This might manifest in clustering and centralization, links formed where links already are. And this might manifest in a preference for participation in watershed management organizations where governments are of the same type. So think a township, which is a lower taxing, lower service delivery organization, might be hesitant to join a watershed management organization with a city that has a lot higher tax rate and a higher service delivery process. So we should see sort of a preference to like organizations fitting with like organizations. And there might be some stability from watershed management forms that have their own taxability. So some of these watershed management organizations or watershed districts that have their own tax base. So on the whole, what I find is that the models that I run really tip the balance more towards gym class. Those local network features are much more predictive of the overall dynamics than are these. And so in general, I think that this is more like gym class. So collaboration by decree, not so fast. Local governments are likely to comply with the least costly element of a mandate, and then you're likely to see declining uptake as costs increase. There's going to be difficulties in joint financing that are going to loom large, even if the tangible fiscal consequences are hard to discern. So people are going to be worried about money, even if you can't find a ton of evidence that their spending changed. And it's not a magic nudge that unlocks hidden benefits of managing water on its own terms, as you might hope. I certainly did at one point. So just to summarize, my contributions in this dissertation are on the nitrate pollution health costs. It's the most comprehensive set of health conditions yet evaluated for associations with nitrate contamination. It's a reproducible analysis, so the workflow can be updated as causal inference on the underlying risk ratios are bolstered. And it elevates the importance of quality of life and distributional questions in water pollution impact research. On the groundwater governance study, it's a detailed descriptive of inferences from a unique case that's useful for a field that is still really just at the theory building stage. And for an overlooked resources of what you should anticipate is not an absence of institutions, but a profusion. And there's opportunities for native leadership, but warning signs of potential structural marginalization reproducing itself. In the Urban Watershed Collaborative study, it adds to a very small set of longitudinal studies of polycentric governance networks. It's a major step in empirical treatment of collaborative mandates, and it sounds a cautionary note about the designs of hierarchical interventions. They're not as easy as you might think. So thank you to my advisors and my committee, to my family and friends for being here, and to colleagues and collaborators. And I'll take questions for the limited amount of time. Yeah, I'm sorry.
Questions, a couple questions? Keep an eye on those online, guys.
Really do want to know this. What is your
Yes,
recommendation for future study, or what does your research lead you to want to find out next?
Well, there's a couple of things. I definitely think that we've only just scratched the surface, so to speak, about what is going on in the Great Lakes region. So I think that both for study and for action, I think is a really interesting arena. And I'm really grateful that that my partners in that collaboration are going to continue doing work, especially with the tribes. I think that in Minnesota, the Board of Soil and Water Resources sort of learned from this study, not my study, but their experience with the Metro Surface Water Act. And now water resources in the state fall under this one watershed, one plan sort of planning guise, but it hasn't, I don't think, been super well evaluated about sort of like how it's different and how, it's another sort of mandate to collaborate. There's money attached at this time, which I think is a big difference. So I've long thought that the one watershed, one plan is an area to study more of. And I think that like the folks that Vine and I have been in touch with around the social cost of water pollution are turning their attention more towards the public health outcomes. And I think probably doing it with a different approach to the underlying causal inference around the nitrate to disease sort of connection. And that, when you look in that study at what the biggest impacts are on the uncertainty, the underlying risk that you assume is due to nitrate is like the major thing that determines the size of the avoided benefit, the avoided costs. So that definitely needs to be tightened up. Not that I'm going to do that, but it should happen for sure. Nishan.
Yeah, so you shared that insight about tribes being less involved in the triangle as well as less likelihood of completing that triangle. So in your opinion, like what can be done to include that or to improve that collaboration so that more tribes can be?
Yeah, that's a really good question. So those statistics, for one, only look at the states in which tribes have a presence. So if you added in those three other states, they would be even more marginalized. I think the states are doing a good job by identifying tribal liaisons across all of the agencies. But I think part of the difficulty here is that the legal rights that tribes have, they sign treaties with the federal government. And so there's a built-in tension here because the federal government in a lot of water policy delegates a lot of authority to the states. But they can't, and they shouldn't delegate their treaty authority to the states. And so frequently what we find happening is that the federal government is in projects or in conversations sort of as a broker relationship where the tribes will will actually sometimes look for a way to get the EPA or the USGS involved in a project that really could potentially only go off with the states. I've also heard that that the tribes feel like their inroads into the states are much more contingent on the administration of the state than is the case with their interactions with the federal government. So I'm not sure if more institutionalization at the state level could prevent that from happening, but it's a lot more informal at that level. So I don't know, it's a significant puzzle, but I think in some ways for the immediate future, thinking about the state, federal, tribal relationship, that triangle as really the focus of attention instead of just the dyadic relationship between the tribe and the state.
I'm gonna close since we're at 3 o'clock. So thank you all for being here.
Thanks.
We'll stay in this room.
Okay.
You still have this until 5.
Yes, yeah.
Yes, so.
What's the last, what's that thing?
The last one, that's that's just from it's the well it's a bit
Yeah.
Anybody wants to take a cookie on their way out, and won't have to this much up. Would you guys like to have this?
just leave it there, I'll deal with it. Yeah.
Alright, so let's see.
Actually, you can, why don't you stop the Zoom on your, or stop sharing?
Okay.
And you can mute.
That's all I want. Yeah.
I guess you stop recording.